All right, so get this, we're diving into Agent I. It's this framework for training large language models to become, get this, self-reflecting agents.
Yeah, AI that can like look at what it does if it's messing up and then course correct, like all on its own. Pretty cool.
We've got a whole research paper, some studies, all about this idea.
The big problem is, right, most AI is trained in this perfect little world. Give it nice data, controlled environment, it does great. Real world, not so much.
It's like, teaching a robot to walk on a flat surface, first bump it hits, it totally wipes out.
Yeah, and that's even worse if the AI has to make a bunch of decisions in a row. One mistake, boom, the whole thing falls apart.
Okay, so Agent R, how does it fix this perfect world problem?
Two parts to it. First part, it uses this thing called Monte Carlo tree search, MCTS for short. It maps out like all the paths the AI could take, the good ones, the bad ones.
Oh yeah, I've heard of that. Like in game AI, it's like exploring all the possible moves, outcomes, right?
Exactly. So Agents R uses that to see where the AI succeeds, where it fails. But then this is the cool part.
I'm all ear.
It doesn't just toss out the bad paths. It actually like zooms in on them, figures out exactly where the AI went wrong.
Oh, so it's self-diagnosing, like figure out, okay, I messed up right here.
Yep. And then it takes the right steps from a good path and basically sticks them onto the bad one. They call this a revision trajectory.
Like a detour on a road trip, hit a dead end, check the map, backtrack, find a new route.
Exactly. It shows how to recover from that specific mistake.
Okay, so that's the reflection part, right? How does the AI actually learn from this?
Phase 2 practice. It takes those revision trajectories, the good ones, and this huge data set called Shared GPT, uses it all to retrain itself.
Like learn from your mistakes boot camp for AI. The more it does it, the better it gets at seeing those critical points and making the right choices.
Right. It's about building that self-awareness so it can even anticipate errors, adjust its plan before it even messes up.
So it's not just reacting, but actually planning ahead.
Yeah, that's the whole point. AI that can handle the real world, no hand-holding.
Sounds good in theory, but does it actually work?
Oh, they tested it. 3 totally different environments, see how it performed across different tasks.
Okay, what were these test environments and why those specific ones?
First one, web shop. It's like a fake online store. The AI had to browse, search, basically go through the whole online shopping experience.
Very real world application. Makes sense. What was number 2?
SciWorld, more about scientific reasoning, like doing experiments, analyzing data, that sort of thing.
So testing its brain power. Got it. And number 3?
TextCraft, they used Minecraft, actually. The AI had to craft stuff, follow recipes, combine materials.
Interesting. Online shopping, science, video games. Really different skills involved there. So did Agent R actually work?
The results were amazing. In all 3 environments, it beat all the existing methods, even some of the best language models out there.
Wow. So not just a little better, but way better.
And here's the kicker. It did better than training on only expert examples. Shows how important it is to learn from mistakes, not just successes.
So those revision trajectories, they really made a difference.
Big time, especially when it came to recovering from errors, being flexible.
Any other interesting findings from these tests?
One thing they noticed, the AI was way better at spotting its own errors, much earlier on, before things got out of control.
So it's not just about bumbling through and getting to right answer eventually. It actually understands when it's messing up.
Exactly. Crucial for anything operating in the real world where things are constantly changing.
This self-awareness, that's promising. Anything else that stood out?
It was much less likely to get stuck in a loop, repeating the same dumb action over and over again.
The AI version of hitting your head against a wall. Not very smart.
Yeah, but Agent R, with its self-reflection, could break free from that. It suggests a much more flexible, adaptable way of solving problems.
So Agent R really aced these tests. Anything that surprised the researchers, anything that didn't go as expected.
One thing they found, which was really unexpected, was that training on multiple tasks at once actually made it better overall. Like learning one skill made it better at a completely different skill.
That's interesting. Makes you think maybe AI doesn't need to be so specialized.
Yeah, maybe this general learning approach is the key to really unlocking their potential. It's like learning to play the piano made you better at chess. Who knows?
Okay, so we've got the problem, the solution, the test, the results. What does this all mean for our listener? What's the takeaway?
This research is huge. It's saying, hey, maybe teaching AI to learn from its mistakes is the way to go, not just showing them perfect examples.
So ditch the perfect world. Embrace the messiness.
Yeah. Imagine AI that not only does things right, but learns, adapts, gets better as it goes, without needing us to hold its hand.
It's like instead of needing an instruction manual for every scenario, it can figure things out on its own, learn from messing up, become more capable.
Exactly. That could change everything from science and healthcare to finance, transportation, you name it.
Wow, lots to think about there. But we've only scratched the surface. The researchers went deeper, different training methods, case studies showing how Agent R fixed specific errors.
Yeah, tons of fascinating details in there.
Sounds like a deep dive for another time.
Definitely. Lots more to unpack.
Well, I think we've piqued our listeners' curiosity with this introduction to Agent R.
Oh, yeah, they want to hear more about how this whole thing works and what it could mean for the future. You mentioned they looked at different ways to train Agent R, like single task versus multitask learning.
Right. So, like, is it better to specialize in one thing or train it on a bunch of different stuff?
Yeah, they wanted to see if, focusing on one thing made it a super expert, or if learning lots of things made it better overall.
So, single task is like, I don't know, a chess grandmaster who only plays chess. Multitask is more like a decathlete competing in all sorts of events.
Perfect analogy. And what they found was multitask actually worked better.
So, doing all these different things made it better at each thing individually.
Yeah, it's kind of wild, like cross training for the mind, learning different skills actually boosts your overall ability.
Huh, that's really interesting. Goes against what a lot of people think about AI needing to be super specialized.
Yeah, maybe that general learning is the key. Like maybe learning piano makes you a better chess player, who knows? But you also mentioned case studies where they showed how Agent R fixed specific errors.
Oh, yeah, those were fascinating. Like seeing it in action, how it actually self corrects.
Yeah, those give you a real peek under the hood. So how about we dive into some of those examples?
Let's do it. So, how did Agent R show off this self reflection in those different environments?
Well, in the web shop one, they had the AI trying to find a specific piece of clothing, like a blue dress shirt.
Oh, yeah, online shopping can be a nightmare even for humans. So many options.
Tell me about it. So the AI did what a lot of people do, searched for just a blue shirt.
Which probably gave it a million results, most of them useless.
Totally. Blue t-shirts, kids' shirts, even blue bed sheets. Way too broad.
So it needed to narrow things down, get more specific.
And that's where Agent R kicked in. It made the AI analyze what it searched for and realize it needed to be more specific.
Like, oh, duh, I need to actually say what kind of shirt I want.
Right. So it added stuff like dress shirt, men's, even a price range, and boom, much better results.
Okay, so Agent R helped it get smarter about its search. What about Spy World? Anything cool there?
Oh, yeah, there was a good one that showed how important it is to catch errors quickly. The task was to figure out if a material was electrically conductive.
So, like, set up an experiment, test it out.
Right. And the AI just assumed it was conductive, so it hooked it up to a battery and a light bulb, expecting it to light up.
But no light, meaning wrong assumption.
Exactly. And that's where the self-reflection came in. Instead of just continuing, the AI was like, wait a minute, went back, thought about it again, came up with a new plan.
Saved it a lot of time and effort by recognizing the mistake early on.
Big time. That's a key part of problem solving. And Agent R seems to give AI that ability.
So Web Shop and Saw World, that's 2 for 2. What about TextCraft, how to do in the Minecraft world?
That one, oh, hey, our listener wants to join in. What's up?
Hey there, which strategy that Agent R adopted is SFT or DPO?
Okay, so you're asking about the strategies the agents use, right?
Yeah, it's a great question. It's not just one strategy they use.
They're using different strategies depending on the situation, for sure.
Well, Agent R is using a few strategies, and they all tie together.
Right, we talked about how they use Monte Carlo tree search and CTS to explore different paths.
Yeah, and that's where they get both good and bad trajectories.
And the key is they don't just throw away the bad ones, they analyze them.
Right, so that's where the model-guided critique comes in, which is super important.
It basically means the AI uses what it knows to figure out when it messed up.
It's not relying on an outside source. It's checking in with itself.
So it can spot errors in real time and use that info to learn.
And then it's also about making those revision trajectories, not just having a bad path or good path.
It's combining a bad path with the correct path to show how to recover.
All these things together are what allows it to self-correct.
So you can think of it as a mix of exploration, self-critique, and dynamic revision.
They work together to help the agent learn from its mistakes.
Okay, that's a great summary of the different strategies. Did that help clarify things?
I hope so. And we are about to get into the TextCraft environment. That's the next one.
Oh yeah, Minecraft crafting. Got to be precise.
No kidding. And the AI messed up, used the wrong stuff, like trying to bake a cake with salt instead of sugar.
Recipe for disaster.
For sure. So Agent R was like, hey, double check that recipe. Basically encouraging it to use the information it had.
Like a helpful reminder to not just wing it.
Yeah. So the AI checked the recipe, saw its mistake, grabbed the right stuff, and made the sword.
Good example of how important it is for AI to use information effectively.
Absolutely. Especially when things are complex, you need to be able to find and use outside knowledge.
Okay, so these case studies, they really show Agent R working its magic across all these different tasks. But I'm curious, how does it actually know when the AI is screwing up? Does it have like an error alarm or something?
Great question. It's all about how they designed its reflection mechanism. That's what lets it self-correct.
Okay, break that down for me. How does the reflection mechanism actually work?
Basically, Agent R uses the AI's own knowledge of the task and the environment. It doesn't need someone to tell it it's wrong. It figures it out itself.
So it's constantly double checking itself. Like, is this actually the right move?
Kind of, yeah. They call this a model-guided critique.
Sounds fancy. What's that mean?
It's how the AI uses what it knows about the task and environment to analyze what it's doing. If things don't add up, it knows something's wrong.
So, like, based on everything I know, this doesn't make sense.
Exactly. And that triggers the whole self-correction process. It's like its internal model is waving a red flag.
Clever. So instead of relying on feedback, it's critiquing itself. Makes it more self-aware, accountable.
Definitely. And this self-critique seems to be why it's so good at avoiding those loops. Remember how we talked about that?
Oh yeah, that was one of the most impressive results.
Well, they dug deeper, and it seems like this model-guided critique is what helps it break free from those repetitive cycles.
How so? How does being self-critical help with that?
When the AI can analyze its own actions and see, hey, I've done this a bunch of times and it's not working, it can try something different.
Like, okay, this is clearly not the answer. Time to change tactics.
Yep. That adaptability, recognizing when something's not working, that's a big part of real intelligence.
I'm seriously impressed with how deep they went into understanding how this whole thing works.
Yeah, they didn't just stop at it works. They figured out why it works, which is really important if we want to understand the limits of this technology.